Good afternoon, sir.
It will not
Good afternoon.
this type of plus 1 by limiting will become 0. To the power n minus.
Yes, sir.
Yes,
sir.
all right.
क्या सुनाई दे रहा है?
Yes, sir.
ओके. सो अभी इसके बाद कोई क्लास नहीं है ना?
No, sir.
ओके. So now we'll start the topic. Diffraction of light. Actually, we are studying physical properties of light or wave. There are three physical properties. One is interference, that is diffraction, and that is polarization. तो इनमें से जो ये दो प्रॉपर्टी है, दिस इज ऑल्सो शोन बाय मैकेनिकल वेव्स. लेकिन ये जो प्रॉपर्टी है पोलराइजेशन, दिस इज द ओनली प्रॉपर्टी ऑफ only shown by electromagnetic waves. Can you give me one example of mechanical wave?
Sound waves.
Yes, sound wave.
String wave.
What? What wave you said? Sound and then someone else?
A string wave.
String wave, yeah. Wave in a string. Yeah, very good. So these are the thing. So can be shown by mechanical wave. This is sound wave. It can show interference. It can show diffraction. But polarization is is the property which only shown by electromagnetic wave. So light is an electromagnetic wave. So light also show polarization. So now our next topic. So this is we have already learned interference of waves, maybe light wave or other wave also. Similarly, diffraction of waves. Now we are going to study. Okay. So, so let's have an example. A very simple setup. Suppose if you have a slit, infinitely long slit. मतलब ये ओपेक है, ये जो बाउंड्री है, स्लिट मतलब है ओपनिंग है, नैरो ओपनिंग है. सपोज यू हैव a narrow opening of a slit B. ओके, सुनाई दे रहा है सब कुछ?
यस सर.
ओके,
Yes.
तो मैं धीरे धीरे स्टार्ट कर रहा हूँ. तो 46 हो गया, तो और 5-6 शायद ज्वाइन करेंगे. ठीक है, उनको ज्वाइन करने दीजिए. So now let us have a very simple experiment. Let's say we have a infinitely long slit. मतलब इसका जो wall है, it goes up to infinity, and we have a very small opening B. Okay. Now you illuminate this slit by a parallel beam like this. Okay. And you put a screen here. Let's say this is a screen. Okay. So normally, if the slit width is large enough, the B is large enough, then what kind of shadow we will see here? So shadow, so this region. So let's say if you draw a straight line here, so then this will be illuminated region. Illuminated, and these two regions will be completely dark. Completely dark. Dark. Okay, so there is no confusion about it. This is the property of rectilinear motion of light. Okay, जो property हम लोग देखे हैं, जैसे refraction, this is extension of that. Okay, so if you have a opaque obstacle on the way of light, so it gives you a shadow. That is the thing we know. Another thing, the boundary between the shadow and dark and illuminated region is very sharp boundary. We will have very sharp boundary. Okay, this is also same thing. You have a very sharp boundary. So now, if you gradually decrease the slit width, so now we have used a plane wave. Let's say plane light wave. Any kind of wave can show diffraction. So it could be a sound or it could be light. So does not matter. So now if you say that this wave has wavelength lambda, then now if you gradually decrease the B, then what will happen? If you decrease the slit width gradually, and at some point of time, if B is comparable to lambda, then a very peculiar thing happens. Peculiar thing in a sense, first, if you gradually decrease and close to lambda, so suppose what is the lambda? What is the lambda of red light? Let's say lambda red is how much? कितना है? रेड का ऑयल लेंथ कितना है? हेलो,
350 nanometer.
360 तो ब्लू का है. सबसे ज्यादा 8000 एंगस्ट्रॉम.
750 sir.
So 8000 angstrom. 8000 angstrom, so that means So now if your B, actually the slit width is compared to 8,000 angstrom, so then something will happen. First, you will see some light will enter gradually in the dark region. Then what will happen? Then you will see the sharp boundary between the dark and illuminated region become blurred gradually. So that means some light will gradually enter to the dark region. So it seems that light is bending towards the dark region. It seems not, it is not true, light never bends. So there is something is happening that some light is actually gradually intruding towards the completely dark region. That means first thing you will see, you won't see sharp boundary of the shadow. ये आप अगर शैडो के आसपास देखेंगे, जैसे मेरा अगर शैडो सनलाइट में देखोगे, आप यू विल सी मेरा क्लियर कट शैडो मिलेगा, मतलब डार्क और बाउंड लाइट के बीच में साफ बाउंड्री मिलेगा. लेकिन इफ यू पुट ए पिन और मे बी लेड पेंसिल हेड, see the shadow, you will see the boundary is not sharp. Okay, so that is what is happening if the wave the slit width is the comparable to the wavelength of light you are using. Then what happens, the light spread. Okay, the light the light the light or wave, whatever the wave spreads towards the dark region. If the slit width, which in our case we are say B, is comparable to wavelength of light or wave, whatever lambda. So that means what happens? So some portion of the light will get intruded like that. So that means the boundary, previously it was sharp, now you have boundary, this much of boundary you will get like this between the shadow and the illuminated region. So let's say this is the delta X. Okay, so that means if actually B is smaller, okay, then actually delta X getting larger. If B is smaller compared to, how much smaller? If it's compared to lambda, then you will have very sharp spreading towards the dark region. So this is called diffraction. Okay, समझ में आ रहा है? हेलो
सर, बट ये ऐसा क्यों हुआ जब बी छोटा हुआ तो डेल्टा एक्स थोड़ा इंक्रीज कर गया?
इसका एक फिनोमेना होता है एक्चुअली. ये जब आई विल एक्सप्लेन दैट व्हेन, मतलब after some time you will see that diffraction is nothing but a class of interference of large number of sources, and those sources are coherent. Okay, so if B become very large, then it's very difficult to have the large number of coherent sources from which the light is coming out and get interfered. So what happens if B is very large? Then what happens? The first condition of having interference between large number of sources is that they should have a constant phase difference between them. That means they should have coherence in nature. So the first condition is not satisfied. So you won't see any interference from a large number of sources. Then there will be no diffraction of light. Actually, we'll see later that diffraction is nothing but interference of large number of sources, infinite number of sources. I will come to that later. Now you just remember that diffraction phenomena happens only when the slit width is comparable to the wavelength of the light people used. इसको बोलते हैं diffraction limit. So now suppose if you have a color light, So suppose if you see, if you use the red light, okay, then your diffraction limit will be 8,000 angstrom. That means if the slit width is comparable to the 8,000 angstrom, then you will see the large amount of diffraction. That means delta X will be large. If you use ultraviolet ray and you use 8,000 angstrom slit width, you may not see that much of spreading of light, but it is comparable to. Now, if you want to see that large number, UV light for that, UV is 3,000 angstrom. So in that case, you will have a blue light or UV light. You can, if you want to see the diffraction, you have to make smaller width, which is comparable to, like, suppose if you use UV or something, lambda, then maybe it will be 3,000 angstrom or something like that. So that means, so if suppose if some application where you need very sharp boundary between shadow and delimited region, suppose lithography, photolithography or something. So in that case, people use mostly क्या बोलते हैं, UV light or blue light for lithographic applications. Red light never been used. Okay. So that is मोटे मोटे अक्षर में, this is the physical phenomena of diffraction of light. Okay. और कोई क्वेश्चन है इसमें? Hello.
No, sir.
Okay.
No, sir.
Very good. So now, in nature, actually, there are two classes of diffraction are observed. So there are two classes of diffraction we observe in nature, and people also क्या बोलते हैं, demonstrated in laboratory also. One is called Fresnel class of diffraction, and another is called Fraunhofer class of diffraction. Okay. So now, what is this actually? So now, in Fresnel class of diffraction, let's say we have a slit here. Okay. Let's say you have a slit, and to observe the diffraction pattern, you need a screen, and obviously you need a source. Let's say source. Okay. So now there are two things. One is the distance between source and slit. Okay. Another is distance between slit and screen. In Fresnel class of diffraction pattern, these two distances are finite. Okay. So first is the distance between ये लिख सकते हैं आप, मैं लिख नहीं रहा हूं. The distance between source and slit and the distance between slit and screen are finite. The distances between source and screen and not screen, slit.
Source and slit.
And slit and screen are finite. Whereas here it is infinite. Okay. So this is the only only one establishment. Okay. Now there is a consequence of that. Okay. So now if you want to have a distance between source and slit and screen finite, so in that case, suppose if you use a point source and then you have a slit here and you have a screen here, then you will see the diffraction pattern like that here and here. So that what happens? So now suppose if you have a point source like that, then you need to have a spherical waveform. Waveform. Okay? Or is
Or we can get cylindrical also.
yeah?
We can get cylindrical also.
Yes. Obviously, spherical, depending on the nature of the source. If it is not point source, then you will have accordingly. So that means for this example, so you need to have a spherical waveform. And now, if you have this kind of obligation that these two distance should be infinite, so we know that any light wave is coming from infinite, so it should be parallel. That means it will be a plane waveform. So if the consequence of this is, so that means you need to have plane waveform to observe the spherical or whatever cylindrical, but not plane waveform. So you cannot see, you cannot be sure. So depending on the nature of the source, but whatever source you use, and if you place that in infinity, you always see that plane wave will come and fall down on the slit. So that means you always have plane wavefront. So that means if you want to see the Fraunhofer class of line diffraction pattern, so you need to have a plane wavefront. Actually, this diffraction pattern is first observed by Fraunhofer by using sunlight. He showed that there are some pattern, diffraction pattern of sunlight. Along with he also made other discovery about the solar radiation, that what some line absorption lines are also present. That is another issue. But regarding diffraction, he first the point pointed out that this kind of diffraction can be observed if you use plane wave front or sunlight, whatever. So now, how can you physically make these two distance infinite? So that means, suppose if you have a slit here, okay, so you need to eliminate this slit by plane wave. Plane wave. So how can you produce a plane wave? So it's very simple. Suppose if you use a lens L1 and now you put a point source here at a focal point of the lens, then you will see, observe a spherical waveform and it will be converted into plane waveform. So now you can say that physically, if you measure that there is a finite distance between the slit and the source, but since it is receding plane wave or parallel wave, you can say the distance is infinite. Okay? Similarly, suppose if you put another lens here, let's say another lens here and focal point, इनकी focal point में, let's say f2, let's say f1, and if you put a screen here, screen, and then what will happen? Then if it will receive a parallel ray from here, from the slit like this, let's say, and they will converge at the focal plane of the convex lens, since the screen is situated at the focal point perpendicularly to the optics axis of the lens, then it will the screen itself is a focal plane. Then what you will see that whatever light will come out from the screen, it will be parallel, so it will be received a parallel ray. So effectively, you say the distance between slit and the screen is infinite. So because here it is receiving parallel ray, here it is emitting parallel rays. So that's why effectively the distance between source and screen, slit and source, they are infinite, and that's why you can see the Fraunhofer diffraction here.
So, sir, Fraunhofer used convex lens and Fresnel doesn't use it.
Yeah, you have to use convex lens, because until unless the parallel ray they converge, you won't see any image. You won't see any parallel. So suppose if they are not if you take out this one, it will just go out.
It will not meet at a point. Yes, sir.
Yeah, if they don't meet together, you won't be able to give any image. So that's why another point that you need to have, since they are, see, in four-number class, the main thing, it should receive parallel wave, it should emit parallel wave, that's all. So suppose this is the slit, so it should receive parallel rays and it should emit parallel rays, whatever may be, bunch of parallel rays like this. Okay, in this way. So one bunch, two bunch, three bunch, like that. Okay. So to see that real image, you need to put one convex lens, and that is how the four-number class of diffraction is executed in laboratory. This is very simple thing because both are finite, so no problem in that. So now in our syllabus, what we have, it's a very long chapter.
हेलो हेलो
सर का आवाज डिस्कनेक्ट हो गया।
हेलो हेलो एवरीवन।
हाँ भाई आवाज आ रही। पावर कट हो गया।
ये तो हमेशा का है।
सर को बाद में लिंक देने बोल दो ना, या फिर कल भी हो सकता है क्लास अगर मन हो तो किसी को।
नहीं सर कुछ टेक्स्ट अब तक नहीं किया, शायद कर लेंगे अभी। Anyways, we'll wait for some time. थोड़ा देर रुक ही लेते हैं।
हाँ ये बेटर आइडिया रहेगा
क्योंकि सर
Yes.
यस सर
In our syllabus, so as I said that we have two class of diffraction. One is Fresnel or another is Fraunhofer. In Fraunhofer, we have a diffraction from one single slit. We have in our syllabus, and we have also in our syllabus double slit diffraction pattern. Okay, so that means two slit will be there, and here only one slit will be there. Okay, and in Fresnel we have zone plate in your syllabus. So first I will teach Fraunhofer diffraction, single slit, double slit, and then we will go for zone plate diffraction, which comes under Fresnel class of diffraction. Okay, so let's start single slit diffraction pattern. Okay, so diffraction. Okay, so now as I said that, so you need to have a slit, infinitely long slit, okay, with a opening, let's say B. So infinite, this is मतलब एकदम एक प्लेट है जो infinite long है और थोड़ा सा खाली है, open है. This is B, okay. And so let's say the slit width is B. So we have infinitely long slit width, infinitely long slit with B. Okay, and then it is illuminated with parallel beam, that means plane wave. So it is illuminated with parallel beam of wavelength lambda. Plane wave of wavelength lambda. Plane wave of wavelength lambda. Okay? And now, so as I said, so that means the source is somewhere, so lens is here and source is somewhere here. So that is how actually a light is coming out from the slit. Okay? So now, so what, so we have to make the arrangement by which it seems that the slit and slit distance is also infinite. So like that means, so we have to put a lens here, convex lens, and at the focal distance of the convex lens, we have put a screen here. At the focal distance, ठीक है? समझ में आ रहा है? Arrangement समझ में आया?
Yes, sir.
Okay. So now let us make a little bit open a little bit because now first job what we have to do. Let's say we have a arbitrary point P on the screen and we are interested to find out what is the intensity of light at that particular point due to the illumination of the single slit of width B by a plane wave of light of wavelength lambda. Okay, this is our job. So now the first job, so this is a plane wave, okay? So the plane wave front is coming like that, like this, and it is somewhere here now. So now the part of the plane wave front will be transmit through the slit and other upper half and lower half it will block. Okay, so now we just consider the time of instance where the plane wave front is situated just here, just in between the slit. Okay, in between the slit. Okay, so now what you can do here? So now let's say the plane wave front is this one. It is coming like that and it is somewhere here. Now what we can do, so every point on the wavefront, we know that from the Huygens principle that each point on the wavefront can emit light, okay? We call them secondary outlet and it will emit actually plane wavefront like that. Like that. Okay? So that means, so if I divide the whole wavefront inside the slit with a large number of equally spaced points, and those points can be considered as secondary source, and those sources are in coherent relationships. That means the phase difference between the sources are constant. So you have a constant phase difference between them. Okay, so that means you have a perfect number of secondary waves. Since they are in constant phase difference, they are coherent sources and they can interfere each other to produce an interference pattern. समझ में आ रहा है? So that is how the total diffraction problem converted to infinite number of converted to interference problem of infinite number of coherent sources. समझ में आ रहा है मैं क्या कह रहा हूं? The first job you have to divide. So पहला तो क्या बोल रहा था मैं कि now since it is producing plane wave, okay, so that means the plane wave inside the slit can be divided. The plane वेव, ये मैं लिखना नहीं चाहता हूं, आप लोग लिखिए, ठीक है। द प्लेन वेव फ्रॉम इनसाइड द slit can be divided into large number of equally spaced point sources. Okay, so these point source, okay, so will emit light, and these point source will act as a coherent sources, and they will produce interference pattern. समझ में आ रहा है? So now let's say these are going to large number of equally, so how much is the number? Let's say we put number of points. Now let's say n, and spacing between two consecutive points, consecutive point की बात कर रहा हूं, 2 points, let's say delta. Then we can say that b is equal to n minus 1 into delta. समझ में आ रहा है ये कैसे आ रहा है? Let's take an example. Let's take this is the slit, and it divided into 3 points. 1, 2, 3 with equal spacing. Let's say delta. ये टोटल कितना है? b slit width. So b equal to क्या है? 2 delta. 2 मतलब क्या है? 3 minus 1 into delta. 3 क्या है? Number of point by which you divided the whole slit. समझ में आ रहा है कैसे ये आया n minus 1 into delta? हेलो?
Yes, sir.
Okay, very good. So we have assumed that it is a discrete point, but it is not so. It is a continuous opening. It's not that we have n number of opening length delta. It's not like that. It is a continuous opening. So to realize that continuous opening, so what you have to do, we have to put a limit where if you put n tends to infinity, then the spacing become almost 0. So mathematically, if you want to translate this discrete point opening to continuous opening, just you have to put a condition limit that n tends to infinity. So for continuous opening of the slit, or continuous opening of the Banham rule, opening of the slit, we have to put n tends to infinity. That means जब आप n tends to infinity करेंगे तो delta tends to 0 हो जाएगा, but always n minus 1 into delta will always give you the total opening. Okay, and you can little bit, if n is very large, because we have put n tends to infinity, you can approximately write this equation as n delta equal to b. समझ में आ रहा है? For large n, ठीक है? So ये हम लोग तो पहले क्या करेंगे? We will calculate the intensity due to the superposition of n number of sources. Okay, then you will put n tends to infinity to get the intensity due to the continuous opening of the slit. समझ में आ रहा है क्या है, क्या बोल रहा हूं मैं? हेलो,
सर एक बार रिपीट कीजिए क्या कहा?
मैं कैसे कर रहा हूं, ये प्रोसेस क्या है? पहले हम क्या करेंगे, ये स्लिट को हम लोग n नंबर ऑफ पॉइंट में डिवाइड कर देंगे. सपोज ये 1 है, 2, 3, let's say 4, let's say this is A1, let's say ये point है आपका A2, let's say ये point है आपका A3 डॉट 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 let's say end point, ठीक है, और दोनों के बीच में गैप कितना है, let's say डेल्टा। समझ में आ रहा है? ये जो मैं बोल रहा हूं कि let us divide the whole slit with a large number of point equally spaced point. What is the large number? Let's say n number of point में आप इस स्लिट को डिवाइड किए हैं, that means the spacing between is delta. Okay, so now what Hylian principle says that each point will act as a point source, okay, and they will emit light from here like this waveform, and this waveform will interfere and produce interference pattern on the screen. Okay, so that is how actually this diffraction problem becomes interference problem, where you have n number of large number of light sources, infinite number of light sources. Okay, then what I will do? Then I will put n tends to infinity. That means number of point will be infinite by which we have divided the slit. If you do so, then the gap between them will close to 0. देखिए ना मैं क्या कह रहा हूँ, जब ए स्लिट को आपने दो हिस्से में डिवाइड किया तो गैप कितना है ये, ना इसको आप तीन हिस्से में डिवाइड कीजिए, 1 2 3, ये गैप छोटा हो रहा है ना, तो
Yes, sir.
if you make n infinite, then delta will become 0, but n minus 1 into delta will always give you b because the opening of the slit is b. Okay, so now what we will do, so let's say, so light is coming out from here, let's say with the like this, okay, ये ठीक है, let's say light here is v1 v2 v3 dot 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 dot, let's say it is vn. Okay, that means light, let's say this is ray number 1 2 3 4 or dot 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 dot, let's say this is n. Okay, so this n number of ray, they will interfere each other and produce interference pattern on the screen. Okay, for a particular point, let's say P, what we'll do, we'll find out the superposition of all this n number of light here. Okay, so now what is the meaning of that? That means we have to find out what is the phase path difference between 1 and 2, 2 and 3, 3 and 4, 4 and 1, and so on like that. So now let's say this parallel beam which is coming out from the slit is making an angle theta with the horizontal axis. Let's say it is theta. Okay, so this will also become theta. Okay, similarly, so now what we have to do, you draw a perpendicular from this A1 point on the A2 B2. So let's say this is your perpendicular. Okay, and this distance we know this is delta. This is the spacing between A1 and A2. I'm going to draw it here again. So let's draw it here. ये फिगर दिख रहा है ना ठीक से?
Yes sir.
मैं इसको ठीक से ड्रॉ कर रहा हूं. Let's say this is your slit. Let's say this is your A1 point. And let's say this is your A2 point. Okay, and now, so this is the one ray number 1, and this ray number 2, 1 2, and what we know that this distance, the spacing between two consecutive points is delta, and we know that this angle, it is theta, and this is also theta. Okay, so now if I draw perpendicular from here, let's say this foot of the perpendicular is A2 dot. Okay, so now you see A1 B1 equal to, let's say this is A2 dot. This is A2 dot. Let's say this is B1 B2. A1 B1 equal to A2 dot B2. तो एक्स्ट्रा कितना पाथ डिफरेंस है दोनों के बीच में? अगर मैं यहां से कैलकुलेट करूंगा तो 1 और 2 के बीच में पाथ डिफरेंस कितना है? जस्ट A2 डॉट है कि नहीं? ये रे 2 रे 1 से इतना ज्यादा ट्रैवल किया है, यही है ना? जियोमेट्री तो ही बोलता है। ये कि सन्नाटा क्यों है भाई? समझ में आ रहा है कि नहीं आ रहा है?
आ रहा है सर।
यस सर।
ये 42 लोग एक साथ सो गया मुझे लगता है। अरे मुझे बेवकूफ बनाने की जरूरत नहीं।
It's afternoon time.
नहीं सर, नहीं सर, हम सुन रहे हैं सर क्लास को।
बोले आफ्टरनून टाइम।
सर नहीं सर, हम सुन रहे हैं सर।
नहीं सर, आ रहा है, समझ रहे हैं।
समझ में आ रहा है सर।
समझ में आ रहा है सर, दोपहर में नींद नहीं आती हमको।
नींद आ रहा है? रात को गेम
No sir, no sir, no sir, it's
नो
fine.
नो सर,
सर दोपहर में नींद नहीं आती है।
अच्छा नींद नहीं आती। वेरी गुड। So now if you apply, so this is perpendicular, so this is hypotenuse, delta your hypotenuse, and this is your perpendicular. So if I
so
put
delta
a
sin
dot
theta.
here, so A2 dot will become delta sin theta. So this is the path difference between 1 and 2. So this is the path difference between ray 1 and 2. Similarly, 2 और 3 के बीच में कितना होगा? Let's say if I draw a perpendicular here, so let's say it will become 3 2 dot. So 2 और 3 के बीच में कितना होगा? Path difference A3
डेल्टा साइन थीटा।
delta sin theta same. So this is the path difference between 2 and 3. Okay, so consecutively ये पाथ डिफरेंस जब मैं एक के रेस्पेक्ट में कैलकुलेट करूंगा, अगर मैं इसको बोलूंगा कितना, ये डबल 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 ट्रिपल होता होता जाएगा। तो इसको ये हम लोग करते हैं। So we know that phase difference is our importance, not the path difference. So the phase difference, let's say phi between 1 and 2, we know that phi equal to 2 pi by lambda into path difference. Path difference कितना है? Delta sin theta. Okay, so similarly 2 and 3 के बीच में भी delta phi होगा, ठीक है? So now if I want to calculate the path difference with respect to 1, तो 1 में path difference phase difference 0 होगा, फिर ये phi होगा, फिर ये 2 phi होगा, फिर ये 3 phi होगा, है कि नहीं? और n में कितना होगा? n में n minus 1 into phi, है कि नहीं?
यस सर।
ये now we can find out what are the क्या बोलते हैं, equation of the wave for each rays. Equation of ray 1 to 3 we can find out. ये समझ में आ गया? मैं ये साफ करता हूँ इधर, ठीक है? अच्छा, ये तो मैंने ड्रॉ ही नहीं किया। इसके बाद क्या होगा? So they will meet here at P. Okay? अच्छा, अगर P इधर होता तो ये रे ऐसे होता, है कि नहीं?
Yes sir.
तो मतलब each point on the screen is nothing but if you change theta, you will get each point on the screen. समझ में आ रहा है? At least in this line. Okay. So now the equation. Wave इक्वेशन फॉर लेट्स से मैं इसको 1 बोल रहा हूं रे 1 लेट्स से मैं इसको बोल रहा हूं E1 तो वेव इक्वेशन हम लोग क्या लिखते हैं हम लोग लिखते हैं एम्पलीट्यूड कॉस ओमेगा टी प्लस फेज लिखते हैं तो हम लोग A1 जो फेज है मैं इसको 0 बोलता हूं ओके सिमिलरली रे 2 का क्या होगा
ए कॉस ओमेगा टी प्लस डेल
फाई होगा बस फाई इनके बीच में डिफरेंस फाई है फेज डिफरेंस जो है और तो कुछ चेंज नहीं हो रहा है ना सिमिलरली रे सी के लिए होगा E3 इक्वल टू ए कॉस ओमेगा टी प्लस T5 तो एन के लिए क्या होगा
n-1
यस ए कॉस ओमेगा टी प्लस n-1 इनटू 5 सो नाउ हम लोग क्या जानते हैं व्हाट इज जब हम लोग एनालिटिकल ट्रीटमेंट ऑफ ये किए थे क्या बोलते हैं इंटरफेरेंस तब क्या करते हैं सुपरपोजिशन किए थे ना y इक्वल टू क्या किया था y1 प्लस y2 है कि नहीं आर्बिट्ररी पॉइंट में करने के लिए तो यहाँ पे क्या है एक की जगह पे n नंबर ऑफ सोर्स है so you will have to add all that so now to calculate resultant wave at P so we have to just put let's say E is the resultant wave we have to do the superposition only dot E तो अभी मैथमेटिक्स हो गया और कुछ है नहीं सो नाउ मैं इसको लेफ्ट साइड साफ कर देता हूं so now resultant wave at P let's say E equal to कितना होगा ए कॉमन चला जाएगा है कि नहीं क्या होगा ये ए तो चला गया cos ओमेगा टी प्लस cos ओमेगा टी प्लस 5 प्लस डॉट ओमेगा टी प्लस n-1 into 5 है कि नहीं तो आवर जॉब
यस सर
out the summation of this one ठीक है मैं इसको बाद में करता हूं आई विल जस्ट राइट डाउन द समेशन सो मैं इसको अभी करता हूं थोड़ी देर बाद तो ये समेशन अगर आप करेंगे सो इट विल गिव यू E इक्वल टू ये स्टेप जंप है यहाँ पे मैं ये स्टेप बाद में करूंगा इट्स नॉट सो इम्पोर्टेंट बिकॉज इट्स मैथमेटिक्स so E will become a sin n phi by 2 divided by I think sin phi by 2 होगा sin phi by 2 cos omega t plus or minus whatever I don't know n-1 divided by 2 into 5. This is the summation. We have a step jump here. We'll do it. Okay. So this is your resultant wave at P. Okay. So now, why we are doing this? Because we need to find out the intensity at P. So now, if I compare this equation, कैसे लिखते हैं? A cos ओमेगा टी प्लस फाइव, ये आपका नॉर्मल वेव इक्वेशन है, ठीक है। तो ये एम्पलीट्यूड है और ये फेज है। So now what is the amplitude of the resultant wave at P? This is the amplitude. Okay. So if I know the amplitude, we can find out the intensity by squaring it. Okay. If I compare with that, then we can write down the amplitude at P of the wave at P, obviously. So let's say it is E theta or whatever is A sine n phi by 2 divided by sine phi by 2. Okay, so this is the resultant amplitude of the light wave at P. So now when we have calculated, what we have considered that the slit is divided by n number of points. So this is not the actual amplitude at P, because in deriving we have already considered that the slit is divided by n number of points, but this is not true. We have a continuous opening like that. There is no fragment like that. So that means what you have to put, we have to put the limit n tends to infinity to get the actual effect of the whole opening of the screen. So now this is for discrete क्या बोलते हैं openings. How many openings? Discrete n number of openings of the slit. But this is not the actual physical condition. Actually, the slit is continuously open. So now for actual continuous opening of slit, we have to produce a put n tends to infinity. So that means consecutively it will give you delta tends to 0, but delta into n will give you b. ये हम लोगों ने पहले बताया. So now what we will do, we will put this limit here and see what is happening here. So let us take
there will be n minus 1, no?
yeah, ये n minus 1
n minus 1.
if n is very large, ये तो बताया ना, n is large, how much large? It's comparable to infinity, then n minus 1 is almost equal to n.
Okay.
Okay, so this is the logic here. So now what we'll take one by one. So let's take n phi by 2. What is the value of phi? Phi equal to क्या है? Phi 2 pi by lambda into delta I है कि नहीं? ये phi है ना आपका? So now if I put it here, n by 2 into 2 pi by lambda delta sin theta, तो आप n डेल्टा एक साथ लिख लीजिए क्योंकि इसको हम लोग लगाना है. तो 2 2 कट जाएगा, theta divided by lambda. So that means n phi by 2 equal to ये n ये b हो जाएगा pi b sin theta divided lambda. Let's say this is beta. ये काम आएगा बाद में, ठीक है, ये एक हो गया. So now we will take this one pi by 2 also and try to convert in terms of beta. Maybe we will take later. Okay. Yeah. So now what we have to do, phi by 2. What is phi? Phi equal to क्या था ये 2 pi by lambda क्या था ये into डेल्टा sin theta है कि नहीं? Let's you multiply with n and divided by n. So that will give you 2 pi b sin theta divided by lambda और into n है कि नहीं? हैं? और एक चीज
Yes, sir.
याद रखना पड़ेगा how what is the value of phi? So phi is what? आप देखिए यहाँ पे 2 pi क्या था ये डेल्टा sin theta by lambda. Okay, what is the value of pi? So now if I put here n tends to infinity, which is delta tends to 0. So that means if I put delta tends to 0, that means phi is very small. So that means you can write sin phi by 2 equal to phi by 2. Okay? So now I'll put here everything. So this one I'll put here. So E theta will become now क्या देगा बताइए ऊपर तो हो गया आपका साइन क्या आया पाई बी साइन थीटा डिवाइडेड बाय लैम्डा और नीचे क्या आया देखिए नीचे तो साइन phi by 2 will become phi by 2. So phi by 2 equal to 2 pi और एक 2 तो रह गया ये 2 कट जाएगा so 2 हट जाएगा इधर pi b sin theta डिवाइड बाय लैम्डा ये जो n है ये ऊपर चला जाएगा ओके so now what is an? What is a? A is actually your amplitude of a one single wave. Okay? ये आपको याद होगा a cos omega t ये 1 का था फिर 2 का a cos omega t plus phi ऐसा है ना ये क्या है ये is the amplitude of one single wave और ऐसे ऐसे करके कितना वेव है n वेव अगर होगा तो सब दोनों मिल रहा है तो आपको क्या देगा it will give you the total wave amplitude of the wave at the slit. That means let's say this is A. Okay, sin pi b sin theta by lambda divided by pi b sin theta divided by lambda where A equal to एक वेव का एम्पलीट्यूड A है ऐसे n है so this is the total amplitude of the all n number of waves. Okay, so now what you can do let pi b sin theta divided by lambda equals to beta. So then your amplitude at P will be become A sin beta divided by beta. Very good. Easy to remember and check. So now intensity at P कितना होगा? Intensity at P, so that means let's say I, which will be amplitude square. Sorry, not A square. E theta square. So that means your I will become A0 square sin square beta divided by beta. Okay, so now what is a0? A0 is I0 sin square beta divided by beta, or beta square. Where I0 equal to A0 square. What is this? अगर बीटा इक्वल टू 0 है, बीटा इक्वल टू 0 मतलब थीटा इक्वल टू 0 है ना, बीटा इक्वल टू 0 मतलब थीटा इक्वल टू 0, थीटा इक्वल टू 0 मतलब क्या है, मतलब ये स्लीट से जो लाइट, सपोज यहाँ पे आपका ये है, ये स्क्रीन है, ये आपका ऑप्टिक्स एक्सिस है, ठीक है। अगर ये जो बीम है यहाँ पे प्लेन वेव आ रहा है, अगर ऐसे ही स्ट्रेट चला जाएगा तब एंगल कितना होगा इसके साथ, थीटा इक्वल टू 0 होगा ना। तो मतलब है इट इज द इंटेंसिटी एट द सेंटर पॉइंट, ये हम लोग आएंगे अभी इंटेंसिटी में। अभी इसको सीध लिख देते हैं, इंटेंसिटी एट थीटा इक्वल टू 0। व्हाट इज थीटा इक्वल टू 0 वी विल explain later. So this is what we wanted to find out. Now our job is to complete the step jump जो हम लोग करने वाले हैं। ये यहाँ तक कोई प्रॉब्लम है क्या?
नो सर।
सर वो लास्ट वाला क्या है, इंटेंसिटी एट पी, उसके बाद में क्या लिखा समझ, उसके बाद क्या क्या समझ में नहीं आया।
ये थीटा इक्वल टू 0, ये देखिए ना यहाँ पे ये i इक्वल टू I0 कब होगा, जब साइन थीटा इक्वल टू 0 होगा ना।
यस सर।
तो ये साइन बीटा 0 मतलब बीटा 0, बीटा 0 मतलब थीटा 0, थीटा 0 कहाँ पे है, यहाँ पे। जब ये लाइट पैरेलल निकलेगा, ऑप्टिक्स एक्सिस ऑफ द लेंस जो है उससे पैरेलल, मतलब सेंट्रल पॉइंट ऑफ द स्क्रीन जो है वहां पे लिख देगा। इसको जीरो ऑर्डर बोलते हैं, हम लोग बाद में आएंगे। जस्ट यू रिमेंबर दिस इज द इंटेंसिटी ऑफ लाइट एट थीटा इक्वल टू 0। इंटेंसिटी एट पी मतलब थीटा इक्वल टू, थीटा में जो इंटेंसिटी है, जैसे मैंने बताया स्क्रीन का ईच पॉइंट हैज देयर यूनिक थीटा वैल्यू, दैट इफ यू चेंज द थीटा you can reach any point of the screen. समझे, मैं 2D की बात कर रहा हूँ।
यस सर।
So now there is a step jump, we have to complete it. So it's very easy, you can also do it as an assignment or मैं कर देता हूँ। तो आपका समेशन क्या था, E था आपका A cos omega t dot cos omega t n minus 1 into 5, ये था ना आपका, इसका समेशन निकालना है ना, है?
यस सर।
ओके, सो नाउ आप बताइए, एक्चुअली मैं इसका समेशन निकाल रहा हूं, तो अच्छा A cos ओमेगा टी मतलब क्या है, आप इसको लिख सकते हैं रियल पार्ट ऑफ A टू द पावर I ओमेगा टी। ये ऑयलर्स थ्योरम में क्या हुआ, e टू द पावर ओमेगा टी cos ओमेगा टी प्लस I sin ओमेगा टी, है कि नहीं?
हाँ सर।
तो हम लोग उसको रियल पार्ट लेंगे तो ये होगा। सिमिलरली आप इसको A cos ओमेगा टी प्लस 5 को लिख सकते हैं रियल पार्ट ऑफ A over I omega t plus 5. So similarly you can write the nth term similar way. ये मैथमेटिक्स है, आप लोगों ने आई थिंक काफी सारे किए होंगे, किया है ना ये प्लस 2 में, सीरीज में नहीं किया था ये, है?
सर किया था सर।
मैं कर देता हूँ, कोई बात नहीं, प्लस, ठीक है। So now we will put this stuff here. एक कॉमन ले लिया, तो मैं रियल पार्ट बार बार लिख सकता हूँ और लिख भी नहीं सकते, राइट, रियल पार्ट ऑफ लिखिए तो क्या आएगा। अच्छा बताइए, ये देखिए e टू द पावर i ओमेगा टी सब में है, तो आई कैन टेक कॉमन। ये आप रियल पार्ट लिख के रखिए। तो पहला टर्म तो 1 रहेगा, सेकेंड टर्म e टू द पावर i5 रहेगा, इस थर्ड टर्म e टू द पावर 2i5 रहेगा, फोर्थ टर्म रहेगा आपका i into n minus 1 into 5। तो ये एक आपका ये रियल पार्ट, ये आपका इनफाइनाइट फाइनाइट सीरीज है, n टर्म जिसमें है, जिसका r है e to the power i5। सो वी नो दैट, वी नो द क्या बोलते हैं समेशन, summation we can write this one, 1 minus r to the power n divided r minus n, है कि नहीं? अरे ये लड़के याद है कि नहीं?
हाँ सर, याद है सर, याद है सर।
तो इसका समेशन क्या होगा? e इक्वल टू, मैं बार बार लिख नहीं रहा हूँ, रियल पार्ट, तो a तो 1 minus r to the power n, r to the power n मतलब e to the power I n phi divided by 1 minus r, है कि नहीं? So now what you do, ये क्या था e, अच्छा e a e to the power I ओमेगा टी, आप इसको e to the power I n phi by 2 से मल्टीप्लाई कर दीजिए, माइनस डिवाइड कर दीजिए, कितना होगा? माइनस I phi by 2 सिमिलरली आप इसको भी e to the power i5 से डिवाइड कर दीजिए, i5 by 2 माइनस ये माइनस होगा तो ये मैंने ज्यादा ले लिया तो इसको डिवाइड करना पड़ेगा, I n phi by 2 divided by e to the power I phi by 2। इसको आप 2 से डिवाइड कीजिए, इसको 2 से डिवाइड कीजिए, तो आपका ये आएगा e इक्वल टू 8 e to the power I ओमेगा टी, ये हो जाएगा साइन n phi by 2, ये हो जाएगा साइन phi by 2, और ये क्या होगा देखिए, ये होगा आपका e to the power एक कम हो जाएगा I into n minus 1 phi by 2, ठीक है? तो आप इसको लिख सकते हैं e इक्वल टू a साइन n phi by 2 divided by sin phi by 2, ये हो गया, और ये रहेगा, मैं रियल पार्ट नहीं लिख रहा हूँ, लिख देते हैं रियल पार्ट ऑफ क्या होगा e to the power I ओमेगा टी, तो इधर से आ गया, इधर से आएगा आपका n minus 1 divided by 2 into 5, इसका रियल पार्ट मतलब cos है, तो ये a sin n phi by 2 divided by sin phi by 2 cos ओमेगा t minus n minus 1 by 2, ये है ना समीकरण। देखिए ये हम लोग यूज किए थे, ठीक है?
यस सर।
Okay. So now our next job is to find out the position of maxima and minima on the screen. तो मैं सोच रहा था कि आज यहीं पे स्टॉप कर देते हैं, तो tomorrow
Yes, sir.
we will have class in the same time 2 o'clock, ठीक है? तो
ठीक है
आप
सर।
अभी जी के साथ
यस सर।
मैकेनिकल के साथ बराबरी में आ गया। तो मैं कह रहा था आप लोगों का तो कितना 44 50 से नीचे आता है अटेंडेंस। हेलो,
Yes, sir.
यस सर।
आप लोग अटेंडेंस तो किसी क्लास में 50 से नीचे ऊपर नहीं जाता होगा।
मैथ में आता है सर।
मैथ में जाता है।
Yes, sir. Maths में 51, 52
मैथ्स मैथ्स में तो अटेंडेंस हम लेते हैं सर इसीलिए।
ये स्कूल थोड़ी है आप लोग जबरदस्ती क्लास में बिठा नहीं, मेरा कहने का मतलब ये बिठाना तो है ही नहीं, आप तो चला के घर जा सकते हो। मेरा कहने का मतलब है क्योंकि मैं सेम चीज दो दो बार दिन में पढ़ा रहा हूँ, वेरी डिफिकल्ट। तो आई वाज थिंकिंग ऑफ हैविंग 6 क्लासेस इफ आई कैन ज्वाइन टुगेदर कि गूगल मीट में 100 बच्चे आ सकते हैं क्लास में।
श्योर सर, वैसे भी कर सकते हैं।
आप एक काम कर सकते हैं, आप दोनों सीआरओ लड़का के विश्वजीत है ना,
यस सर।
विश्वजीत से बात करके आप दिन में 6 क्लास का शेड्यूल बनाइए एक हफ्ते में। तो कल कल एक बात देखिए, वो 2 बजे उन लोगों का खाली रहता है। हेलो,
एक मिनट सर, टाइम टेबल देख रहा हूँ।
अरे एक मिनट, आप एक काम कीजिए, आप बात कर लीजिए। आपका 10 बजे खाली नहीं है ना कल?
सर कल तो फ्राइडे है सर।
अरे तो कल 10 बजे उन लोगों को बोलिए ज्वाइन करने के लिए।
ठीक है सर।
ठीक है, कल ही बात कर लेंगे। 9:30 को ज्वाइन, सॉरी 10 ओ क्लॉक ज्वाइन कर लीजिए, वरना मेरी डिस्कशन कर लेंगे, देन विल स्टार्ट द क्लास। अभी दोनों 2 क्लास बराबरी में है। ओके ठीक है फिर। अच्छा, इसमें कोई प्रॉब्लम तो नहीं है ना अभी?
नहीं है सर।
नहीं सर,
नो सर।
नहीं सर।
नो सर।
ओके वेरी गुड,
Okay.
सी यू टुमारो 10 o'clock।
यस सर।
यस सर, गुड डे सर।
गुड डे।